Hi, this is Betsey Altman. Today we'll be talking about wired versus wireless networks. First of all, let's discuss what is a wireless network. A wireless network uses radio waves to connect devices rather than cables. There aren't any cables of any kind connecting the devices on a wireless network. Within a wireless network, there's four main types. The first is a wireless local area network, otherwise known as a LAN. A LAN is when two or more devices are connected wirelessly. The second type is a metropolitan area network, also known as MAN. MAN wireless networks connect several wireless LANs together. Then we move on to a WAN, which is a wireless wide area network. A wide area network, just as its name states, covers large areas such as neighboring towns or cities. School districts, for example, would be considered a WAN, while the school within a district has its own LAN. Then we go to a much smaller type of wireless network, which is a personal area network, also known as a PAN. Personal area networks connect multiple devices that are within a person's reach. For instance, your laptop, cell phone, and possibly any other device that is within your reach at the moment would be considered a PAN. From there, we have a wired network. So, what is a wired network? Wireless networks do not connect wirelessly using radio waves like the wireless networks do. They are connected using physical cables. Cables are connecting each device to one another. These devices that are connecting could be using Ethernet cables, routers, and switches that pull all of the devices into one another. These devices are connected using the peripheral devices are connected using USB connections and other types of connections. To really understand how these relate, we would need to look at the OSI model. The OSI model is a conceptual model used to organize data communication over networks. OSI standing for Open Systems Interconnection. There are 7 layers to the OSI model. And again, this is a conceptual model. So it's not a physical being. It's just a conception to help us understand how these networks communicate and transfer data between each area. So the 7 layers include from the bottom up, physical, data link, network, transport, session, presentation, and finally, application. So let's start at layer 1, the physical layer. This is the bottom layer. It, as its name states, addresses physical aspects such as the cables, repeaters, hubs, and etc. that are included with the network. It specifies electrical characteristics of the signals. The devices that might be found at this layer are cables, repeaters, hubs, and connectors. From there, we move on to the data link layer. From this layer, meanings are assigned to the bits that are transmitted. The packets are addressed, and there is error detection and correction provided at this layer. The media access control and the logical link control are used to establish links on this layer. Then we move on to layer 3, the network layer. This is where the routing occurs for network messages. The IP and IPX protocols create logical addresses for the devices, such as routers that are found on this layer. Moving to level 4, this is the transport layer. This is the basic layer at which devices communicate with other devices on the network. The TCP protocol works at this layer, and it ensures that packets move through the network without errors. This layer establishes connections and acknowledges when the packets have been received from other layers. If packets are corrupted or there is an error within the packet, this layer will resend the packet. If there is a large piece of data, this layer divides those messages into multiple smaller packets that arrive each in order at the next device. The session layer, or layer 5, establishes and maintains communication. The session has to be established before the data can be transmitted. The presentation layer converts data from one type of representation to another. In order for devices to connect and communicate with one another, they may be using different types of data. So in order for them to understand the data from another different device, then this layer will convert the data so that it is legible to another device. This layer also encrypts and decrypts the data before and after transmission. The top layer of our OSI model is the application layer. This is where application programs interact with the network. For instance, Hypertext Transfer Protocol, or HTTP, would belong on this layer. This layer does not mean this is where the applications are, but this is how the data communicates with the applications on the network. So now that we've looked at wireless data networks and wired data networks, let's take a look at how they differ. They differ mostly on the physical and data link layers. If we take a look under wireless, we see that devices are connected through wireless radio waves. These waves are sent between wireless access points. To the contrary, wired devices are connected through cables. These cables send data through the network to the multiple devices. Ethernet network interface cards are used on a wired network. On wireless networks, however, they use WLAN network interface cards, wireless rather than Ethernet. The drawbacks of the wireless network are loss of signal and the distance from the wireless access points, which can cause a signal degradation. Therefore, it's important when designing a wireless network to ensure that your wireless access points are put in places that can be easily accessible to your devices. Wired networks also have a few drawbacks. Whereas wireless networks will allow users to interact remotely with the network and move around, wired networks are very limited in movement. And many times, users are spending most of their time in one spot, requiring a static position. Wireless networks also present some security issues that wired networks would not have. For instance, wireless networks are subject to interference and disruption. For this reason, repeaters should be utilized to boost the signal. Therefore, there's less interference and less disruptions with the service. Wireless networks can also be easily attacked maliciously by anyone within range of an access point. This is why it's imperative to use multi-layer security such as firewalls, and have anti malware software installed on all of your devices, even devices that are bring your own device. This way, the wireless network is more secure. Also, another security risk is that unauthorized users can easily gain access through a wireless network, more so than they can with a wired network. For this reason, it's very important to limit access, employ user authentication, and to encrypt the data that is being transferred across the network. Thank you so much for your time today. I hope you learned a little bit about wired and wireless networks.